Okay, so welcome back. So what we're going to do is, we are going to, keep stepping on things. So we're going to look at using the remainder theorem, synthetic division, to help us decide whether a given k value is a zero. Okay, now remember, k can be any complex number. So real numbers are also complex numbers. So guess what? We're going to do an example of where I give you a complex number. So again, make sure you're able to do those. Practice. Okay, so I'm going to show whether, so what we want to do is we want to use the remainder theorem and synthetic division to decide whether the given number is a zero of the given polynomial function. Okay, so now let's do A. So so we're given this polynomial function and this is our k value. So what we're going to do is we're going to do synthetic division. Our k value is 1, so we're going to put 1 here. Okay? And so what we're going to do is we're just going to do synthetic division, find the remainder. If the remainder is 0, then k is a 0 of the polynomial function. If we get anything else, then the answer is no. It is not. Okay, so we're going to put the coefficients. So again, are there any missing terms in here? And the answer is no. So we're just going to put 1, -4, 9, and -6. Okay? And so what we're going to do is we're just going to do synthetic division. So it's going to be 1, 1, -3, -3, 6, 6, 0. And so look at that. We get 0. So that means k is a 0. Yes. K is a 0. Okay? K equal to 1 is a 0. Okay? Okay, now let's do the next one. That was pretty easy. Okay, now let's do the next one. So now we're going to use this polynomial with this k value. So let's do B now. So now we're going to do, again, we're going to do the synthetic division. Now be careful, this k value is -1 now. So we're going to put -1 here. And now watch out, we need some place values here. So it's going to be 1, 0, 1. So 1, 0, 1. So 1, 0, 1, -3, 1. So -3, 1. And so here's my numbers. So now I'm going to do the same thing. I'm going to drop down. So this is 1, and then -1, -1, 1, 2, -2. Well, we get -5, and we get 5, and we get 6. So let's make sure we did that right. Okay? So we drop the 1 down. -1 times 1 is -1. 0, that gives us -1. 1, 1 plus 1 is 2. -2, -5, 5, and we get 6, and this is our remainder. So the remainder is not 0. Therefore, no. K equal to -1 is not a 0. Okay? Now let's do C. So now we're going to use this polynomial and we're going to find out whether this is a root, or excuse me, a 0, right? So now we're going to do the same thing. So this is our k value, so we have to put 1 plus 2i, okay? And now we're going to write the coefficients. Again, we need to make sure if there's any place value. So 4, 3, 2, 1, 0. So no, so we're going to do 1. And then we're going to do -2, 4, 2, and -5. Okay? So we want to make sure that we have it all there. Okay, so now, what do? Now, we're going to do the same thing. So we drop the 1 down. Okay, now this is where you have to be careful because we're dealing with complex numbers. Okay, so now this times this gives us what? 1 plus 2i. Now we're going to add down, right? So now we're going to do real with real, right? This is the imaginary part, this is the real part. This is real, goes with real. So this is going to what? Negative 2 plus 1 is negative 1 plus 2i. Now, we're going to take this times this. So this is where we have to go over, we have to do some scratch work. Okay? So this is going to be 1 plus 2i times negative 1 plus 2i. And so again, you have to remember how to multiply complex numbers. So this is going to give us a negative 1. This is going to give us what? This is going to give us plus 2i minus 2i, what? Plus 4i squared. So this is going to cancel with this. We're going to get a negative 1 plus a negative 4, which gives us a negative 5. And so this is going to give us a negative 5 here. And now we're going to add down, and we get what? Negative 1. Well, this times negative 1 is just going to be what? Let me move this over. So negative 5. This is going to give us a negative 1 minus 2i. And now look, I'm going to do the same thing. Now I have to multiply again. So let's do that. So it's going to be 1 plus 2i times negative 1 minus 2i. So let's see what happens here. We're going to get a negative 1. Then we're going to get a negative 2i. Then we're going to get another negative 2i. Okay? And then we're going to get a minus 4i squared. Okay? Now this one's not going to simplify as easily. So this is going to be negative 1 minus 4i plus 4. So this is going to be what? This is going to give us a 3 minus 4i. So that's what we're going to get here. Okay? Oh, I messed up. Hold on. Ah! I messed up. I didn't add. Scratch that. Oh, I hate when I do that. Okay, I forgot to add. So I got ahead of myself. I was so excited about doing another multiplication, I got excited. So forget that. So let's start over. I dropped the 1, right? I multiplied by 1 to get this one. And then I multiplied, and then I added down, right, to get this. And then I multiplied these two, and that's where I got the negative 5. And then I added down to get negative 1, and I multiplied this by negative 1 to get this. Now I'm going to add, so I forgot to add. So now I'm going to get 1 minus 2i. Oh, that'll be easier. So that's going to be easier to deal with. So now let's do it again. So now I'm going to do 1 plus 2i times 1 minus 2i. And so what am I going to get? Well, I'm going to get 1 plus 2i minus 2i minus 4i squared. And so again, these are going to cancel, and I'm going to get 1 plus 4, which equals 5. So I get a positive 5 this time. And I get a 5, and guess what? I get a 0. And lo and behold, k equal to 1 plus 2i is a 0. So yes, it is a 0. And that's it. That's how you test it and decide whether you have a k value that's a 0 of a polynomial. Have a great day.